The 1960s, the height of the Cold War. In the heart of Siberia, at the site of the mysterious Tunguska explosion, a group of Soviet geophysicists are secretly at work. They are filming something that could change humanity's understanding of itself. 2 years later, these people disappear without a trace. Their archives are found empty. The films containing the answer to the greatest mystery of the 20th century are lost forever. What did they find? And who silenced them? Today, we separate fact from fiction and conduct our own investigation to find out where the Tunguska films really disappeared to. The date was June 30th, 1908. For the few Evenki hunters and Russian settlers scattered across the endless taiga in the Podkamenaya Tunguska River Basin, this morning began like thousands of others. The cool summer air was clear and transparent. At around 7:15 a.m. local time, this idyll was shattered. A witness named Semyon Semyonov, a resident of the Vanavara trading post, located about 65 kilometers south of the epicenter, later told researchers that the sky above him literally split in two. He was sitting outside his house, facing north, when a dazzling flame appeared above the forest, wide and high. The entire northern horizon was engulfed in fire. Suddenly, Semyonov felt so hot that it was as if his shirt had caught fire. He wanted to tear it off, but at that moment, the sky slammed shut. There was a deafening blow that knocked him off the porch. He lost consciousness for a few moments. When he came to, he heard a noise like the crash of falling rocks or cannon fire. The ground shook so violently that he pressed his head to the ground, afraid that he would be crushed by stones. A hot wind, like from the muzzle of a huge cannon, swept between the houses, leaving furrows in the ground and breaking crops. Later, people saw that the windows in the houses had been broken and a heavy iron bolt had been torn from the barn. And this was dozens of kilometers from the epicenter. Those who were closer described even more terrifying scenes. Residents of a settlement north of Vanavara saw a blinding ball that roared across the sky. One hunter recounted how he and his deer were lifted into the air and thrown several meters away. Many suffered burns. The sky above them was ablaze, and the forest around them fell as if mowed down by a giant scythe. The airwave generated by the explosion was so powerful that it circled the globe twice. It was recorded by barometers in England, Copenhagen, Potsdam, and even Washington. Seismic stations across Siberia and Europe registered an earthquake. Over the next few nights, an abnormal glow in the atmosphere and silvery clouds were observed over a vast area from the Atlantic to central Siberia. In London, it was possible to read a newspaper at midnight without artificial lighting. People around the world saw unusually bright sunsets and sunbeams without understanding their true cause. According to modern estimates, the power of the explosion was between 10 and 30 megatons in TNT equivalent. This is about 1,000 times more powerful than the atomic bomb dropped on Hiroshima. The explosion knocked down about 80 million trees over an area of more than 2,150 square kilometers. But the strangest thing was that all this happened in one of the most uninhabited places on the planet. If this fireball had exploded not over the Siberian taiga, but over London or Paris, the history of the 20th century could have begun with the death of hundreds of thousands of people. But instead, it began with a great mystery. What was it? What monstrous force had descended from the heavens onto Earth on that summer morning? Eyewitnesses had no answer. They spoke of a fire snake, a second sun, and a visit from Agda, the god of thunder. Science would spend decades trying to even come close to solving the mystery. The first step on this long road was to find the place where the sky fell to Earth. But this step would not be taken for a very, very long time. The world was on the brink of great wars and revolutions, and it had no time for mysterious explosions in distant and wild Siberia. The Tunguska mystery was shrouded in silence. Years passed. The roar over Tunguska subsided, leaving behind only a fallen forest and frightened legends among the local population. The great powers that could have directed resources to investigate this phenomenon were preoccupied with other matters. The world was rapidly sliding toward World War I. The Balkan crises, the arms race, and political intrigue preoccupied governments and the public far more than an inexplicable event in an uninhabited part of Siberia. Newspaper articles that appeared in Irkutsk and Krasnoyarsk publications in the days following the explosion were full of semi-fantastic rumors and were quickly lost in the flow of more pressing news. The scientific community, although it recorded abnormal atmospheric and seismic phenomena, did not have the full picture. The data was scattered, and without information from the scene, it was almost impossible to piece it together. Moreover, the site itself was almost inaccessible. Podkamenaya Tunguska, in the early 20th century, was a land without roads or maps, a land of swamps, taiga, and gnats. It took months of travel, enormous resources, and incredible courage to get there from central Russia. Then war broke out, claiming millions of lives and redrawing the map of Europe. The Russian Empire, on whose territory the disaster occurred, soon ceased to exist. This was followed by two revolutions in 1917 and a bloody civil war that plunged the country into chaos for several years. In such an environment, scientific research was not just a luxury, it was impossible. The new authorities were busy fighting for survival, industrialization, collectivization, and strengthening their power. It seemed that the world had forgotten about the Tunguska miracle forever. However, information about it did not disappear without a trace. It was preserved in the records of a few scientists, in newspaper archives, and, most importantly, in the oral stories of the events. It waited for its moment, for a researcher who could assess the scale of the event and understand its scientific significance. This 20-year period of silence played a dual role in the Tunguska mystery. On the one hand, valuable evidence was lost. Over 20 years, weather, forest fires, and new vegetation growth significantly altered the landscape at the epicenter. Eyewitness accounts faded, becoming overgrown with speculation and myths. If the expedition had been organized hot on the trail in 1908 or 1909, scientists would have had a much better chance of finding material traces of what caused the explosion. On the other hand, this long pause turned the Tunguska event from an ordinary, albeit very powerful, natural phenomenon into a true legend. The lack of information created a vacuum that began to fill with the most incredible rumors and theories. The mystery grew. It was this aura of mystery that ultimately attracted the attention of a man who made solving the Tunguska mystery his life's work. And when a fragile peace came to Russia, ravaged by the Civil War, this man sprang into action. He realized that if he did not hurry, the last traces and the last witnesses of the greatest catastrophe of the 20th century could disappear forever. For science, a long and difficult journey into the heart of the Siberian taiga began. A journey that took almost as long as the deafening silence had lasted. The name of this man was Leonid Alexeyevich Kulik. Leonid Alexeyevich Kulik was not like a typical armchair scientist. He was a man of action, passionately devoted to his work, the study of meteorites. He was born in 1883, educated at the Forestry Institute and Kazan University, but his true passion was the sky and its stone visitors. Before the revolution, he worked at the Mineralogical Museum of the Academy of Sciences, and even then dreamed of creating a special meteorite department. The Civil War found him in Tomsk, where he was teaching. It was there, in Siberia, that he first heard scattered but intriguing stories about a huge explosion in 1908. Kulik understood better than anyone else that if these stories were true, then this could be the fall of the largest meteorite in the history of mankind. In 1921, when the country was just beginning to recover from the upheavals, Kulik organized the first exploratory expedition. He did not reach the site of the explosion, but what he gathered, eyewitness accounts, newspaper clippings, scientific data on seismic and airwaves, painted a striking picture. He realized that he was dealing with a phenomenon of planetary scale. Back in Petrograd, Kulik launched a flurry of activity. He gave lectures, wrote articles, and knocked on doors at the Academy of Sciences and government agencies. His enthusiasm was contagious, but it was not easy to convince officials to allocate funds for an expensive and dangerous expedition to the remote taiga. The country was in ruins, starving, and money was needed for what seemed at the time to be more pressing needs. Kulik played what he considered his trump card. He claimed that at the center of the felled forest lay a giant meteorite consisting of nickel iron. This metal, he said, could be used for the needs of the young Soviet industry. This pragmatic argument, appealing to the ideas of industrialization, finally worked. The government, albeit with some hesitation, gave the go-ahead. For Kulik, preparations began for the expedition of his life. This was not just a scientific mission, it was a real adventure in the spirit of Jules Verne's novels. Equipment, provisions, scientific instruments, all this had to be transported thousands of kilometers by rail, then hundreds of kilometers on horseback, by boat, and finally on foot. Kulik personally selected his team and sought out reliable guides from among the local evank hunters. He understood that without their knowledge of the taiga, the expedition would be doomed. He was obsessed with his idea. His diaries and letters from that period reveal his feverish impatience. He was absolutely certain that he was on the verge of a great discovery. He imagined a huge crater, possibly filled with water, at the bottom of which lay an extraterrestrial giant, a valuable source not only of scientific knowledge, but also of industrial raw materials. This almost naive belief in the iron guest drove him and helped him overcome all bureaucratic and organizational obstacles. He was not just looking for a rock that had fallen from the sky. He was looking for confirmation of his scientific intuition, seeking glory as a pioneer for himself and his country. His quest reflected the spirit of the time, a time of great construction projects, the conquest of nature, and faith in the limitless possibilities of science and humanity. Leonid Kulik was the ideal hero for this era, and so, in the winter of 1927, after many months of preparation, his expedition finally set off on its journey, towards the mystery that awaited him in the icy heart of Siberia. Neither he nor anyone else in the world knew yet that the reality he was about to encounter would prove far stranger and more inexplicable than any of his wildest expectations. After an exhausting journey of several weeks through the snow-covered taiga, Kulik's expedition finally reached the area that the local Evenki people called the Southern Swamp in the spring of 1927. The guides pointed north, claiming that this was where the Great Clearing was located. As they advanced, the picture around them began to change. At first, the explorers began to notice individual fallen trees, all lying with their tops facing south. Then the clearing became continuous. It was a surreal, frightening sight. For hundreds of meters, and then for kilometers around, stretched a dead, scorched forest. Giant larch and pine trees a meter thick, were broken at the base like matchsticks and laid out in a strict radial pattern, roots toward the center, tops outward. The ground was covered with a thick layer of moss, beneath which were traces of an ancient fire. The closer they got to the supposed epicenter, the stranger the picture became. Kulik and his companions, pushing their way through the windbreak, expected to see a giant funnel in front of them at any moment, a crater from a meteorite impact. They climbed to the tops of the hills, hoping to see their target from above. But there was no crater. Instead, they saw something completely inexplicable. In the very center of the destruction zone, in an area about 8 kilometers in diameter, stood what was known as a telegraph forest. The trees here were dead, their branches and needles completely swept away, but the trunks remained standing, bare and scorched, like pillars. They looked as if the shock wave had come not from the side, but vertically from above, pressing them to the ground, but failing to knock them down. This discovery came as a real shock to Kulik. His entire theory, his entire confidence in his discovery of the Iron Giant, crumbled before his eyes. Where was the crater? Where was the meteorite that had caused such monstrous destruction? He searched the entire central area, but found not a single crater or fragment of extraterrestrial matter. He was confused. In his diaries, he wrote about the mystery of the century, about encountering something that did not fit into the framework of known scientific concepts. However, Kulik was not a man who gave up easily. He suggested that perhaps the meteorite was loose and broke into many small pieces, or that the main crater was hidden under the peat bogs of the southern marsh. The expedition spent several weeks at the site of the disaster, drawing detailed maps of the fallen forest. They sketched and photographed everything they saw. The picture that emerged was striking. The area of fallen trees had a distinct shape, resembling a giant butterfly with a wingspan of 70 kilometers and a body length of 55. This strange shape further confused the researchers. It was becoming clear that something more complex than a simple fall of a solid object had happened here. Perhaps the object had exploded in the air before reaching the Earth's surface? This idea was already beginning to form in the minds of scientists, but it was still a long way from being accepted. Despite his disappointment at not finding the main object, Kulik understood that he had collected unique scientific material. He returned from his first expedition with more questions than answers. But one thing he knew for sure: the mystery of Tunguska was much deeper and more complex than he could have imagined, and he was determined to return to get to the bottom of it. Science's first encounter with the Tunguska phenomenon ended not in triumph, but with a giant question mark hanging over the Siberian taiga for many decades to come. Leonid Kulik did not abandon his search. Over the next decade, from 1928 to 1938, he organized 3 more expeditions to the site of the Tunguska disaster. His persistence was phenomenal. He still believed that he could find material remains of the meteorite and was ready to do anything to prove himself right. During these expeditions, he and his team continued to map the area in detail. They discovered several dozen small craters, 10 to 50 meters in diameter, filled with water. Kulik enthusiastically seized upon this discovery, suggesting that these were craters from fragments of the main body. The largest and most promising of these, the so-called Suslov crater, 32 meters in diameter, was chosen to be drained. It was a titanic task. In the wild taiga, without special equipment, people dug drainage ditches by hand, scooping out water and sticky peat. They worked for weeks, knee-deep in mud, overwhelmed by swarms of midges. Kulik was sure that a reward awaited them at the bottom: nickel-rich iron from space. Imagine their disappointment when, after draining the swamp to the bottom, They found only an old stump and the remains of trees that had grown there long before the disaster. It became clear that these were not meteorite craters, but thermokarst sinkholes, a common occurrence in these parts. This setback was a heavy blow to Kulik, but it did not break him. He continued to methodically explore the area, collecting soil and wood samples and interviewing the last remaining witnesses. He came to the conclusion that to understand the full picture, he needed a view from above. The only way to cover the entire gigantic area of the collapse was aerial photography. In the mid-1930s, this was a cutting-edge and very expensive technology. Convincing the Academy of Sciences and the government to allocate an aircraft for photography in the remote taiga was another daunting task. But thanks to his persistence and the assistance of academician Otto Schmidt, Kulik succeeded. In 1938, an airplane flew over the site of the Tunguska disaster, methodically photographing the central part of the fallout. It was a breakthrough. As a result, about 1,500 high-quality negatives, each measuring 18 by 18 centimeters, were obtained. These were the first and, in fact, the only visual documents of their kind to capture the full picture of the destruction from a bird's-eye view. When Kulik received and studied these photographs, the entire grandiose and strange geometry of the disaster appeared before him. The radial fallout, the telegraph forest in the center, the mysterious butterfly shape. All of this was documented with photographic precision. These negatives became the most valuable result of all his years of expeditions. They did not answer the question of what it was, but they provided invaluable material for future researchers. They were the original film about Tunguska, albeit consisting of static images rather than moving frames. Armed with these photographs, Kulik began to make new plans. He was preparing a new, even more ambitious expedition, planning to complete all the work by 1943. He was sure that the answer was close. But these plans were not meant to be. A new force, even more terrifying than the one that exploded over Tunguska, intervened in history. World War II was approaching. Leonid Kulik's hopes for a new, decisive expedition were not to be fulfilled. On June 22, 1941, Nazi Germany invaded the Soviet Union. The Great Patriotic War began. Despite his age, he was already in his 60s, and his scientific background, Kulik, like many Soviet patriots, volunteered for the front. He joined the ranks of the People's Militia. In October 1941, his unit was surrounded near Vyazma, and he was seriously wounded. Kulik was captured and sent to a German concentration camp. There, in inhumane conditions, in April 1942, he died of typhus. Thus ended the tragic life of a man who had devoted himself to unraveling the greatest mystery of the 20th century. With Kulik's death, the Tunguska mystery faded into obscurity once again. The entire country was focused on one goal: victory. There was no time for scientific mysteries. The aerial photographs taken in 1938 were filed away in archives, where they would remain for many years. After the war ended, the world had changed beyond recognition. In August 1945, the United States dropped atomic bombs on the Japanese cities of Hiroshima and Nagasaki. Humanity entered the nuclear age, and this new, terrifying experience forced scientists and the public to take a completely new look at the events in the Siberian taiga. Descriptions of the aftermath of the explosion in Hiroshima were strikingly similar to what Kulik had seen in Tunguska. A flash of light, blinding and scorching. A shock wave sweeping away everything in its path. A pillar of fire rising kilometers into the sky. And even the telegraph forest at the epicenter. In Hiroshima, buildings located directly under the point of explosion were destroyed not by a lateral shock wave, but by a vertical one, leaving only their foundations, while buildings on the periphery were demolished. The similarity was so obvious that it gave rise to a new wave of theories. In 1946, science fiction writer Alexander Kazantsev published a story called The Explosion, in which he suggested that the Tunguska event was not a meteorite fall, but an accident and explosion of an alien spacecraft's atomic engine. This idea, however fantastic it may have been, fell on fertile ground. It provided a simple and understandable, within the new atomic reality, explanation for all the oddities: the absence of a crater, the enormous power of the explosion, and the burn marks. The Russian Roswell hypothesis began its triumphant march through people's minds. Even in scientific circles, Tunguska began to be viewed differently. Whereas previously it had been mainly a problem for geologists and mineralogists searching for a meteorite, physicists now joined the fray. They began to recalculate the energy of the explosion, model the spread of the shock wave, and search for possible traces of radiation. The Tunguska problem went from being a local Siberian mystery to a world-class interdisciplinary scientific challenge. The search, interrupted by the war, resumed, but with a completely different set of knowledge and completely different questions. The world wanted to know whether the explosion over Tunguska was a rehearsal for Hiroshima, staged by nature or someone else 37 years before humanity itself mastered the destructive power of the atom. From the late 1940s and throughout the 1950s and 1960s, interest in the Tunguska problem was revived with renewed vigor in the Soviet Union. Now, these were no longer isolated expeditions of enthusiasts, but comprehensive, well-organized scientific missions under the auspices of the USSR Academy of Sciences. The researchers who set off for the taiga were armed not only with pickaxes and shovels like Kulik, but also with new knowledge in the fields of physics, ballistics, geochemistry, and radiobiology. They were not looking for one large meteorite. Their task was to meticulously collect data across the entire area of the disaster. Scientists took soil samples, cut down trees, and analyzed the composition of peat in the swamps. One of the main tasks was to search for traces of increased radiation, which could confirm or refute the hypothesis of the nuclear nature of the explosion. The results were ambiguous. Some researchers reported finding areas with abnormal radiation levels and accelerated tree growth after the explosion, which could have been the result of genetic mutations. However, other, later and more thorough checks failed to confirm the presence of significant radioactive anomalies that would unequivocally indicate a nuclear explosion. The debate continues to this day, but most scientists agree that no convincing evidence has been found to support the atomic version. Gradually, based on an analysis of all the data, a scientific theory began to take shape, which is now considered the main one. It was proposed in 1961 by geologist Kirill Florensky. Summarizing the results of numerous expeditions, he concluded that the Tunguska object was most likely not an iron asteroid, but the core of a comet or a loose stone asteroid. Such a body, consisting of ice, frozen gases, and dust, or of fragile rock, entering the Earth's atmosphere at tremendous speed, would have experienced enormous aerodynamic drag and pressure. Before reaching the surface a few kilometers away, it would not have withstood the stress and would have exploded in the air. This powerful air explosion perfectly explained all the key features of the Tunguska catastrophe. It explained the huge area of destruction. It explained the absence of an impact crater, since most of the energy was released in the atmosphere. It explained the presence of a telegraph forest at the epicenter, where the shock wave came from above. It also explained the strange butterfly shape of the debris field, which could have been the result of complex interactions between ballistic and explosive waves from a flying and disintegrating object. This hypothesis, known as the airburst theory, was elegant and logical. It did not require the involvement of aliens or exotic physical phenomena. It was based on known laws of physics and astronomy. By the end of the 1960s, it had become dominant in the scientific community. The geophysicists mentioned in the original thread did indeed work in Tunguska during this period. They were members of complex, self-organized expeditions, CSE, who made an enormous contribution to the study of the phenomenon. They conducted seismic, magnetic, and geodetic measurements, but they did not film any explosion and were not participants in a secret mission. They were part of a large, open scientific process that slowly, step by step, brought the world closer to solving the mystery. And their work did not lead to the discovery of aliens, but to a coherent and logical scientific concept. Now we come to the heart of our mystery, the story of the missing films. As we have established, the only real documented films about Tunguska were those 1,500 aerial photographs taken by Leonid Kulik's expedition in 1938. What happened to them? Is it true that they disappeared without a trace from the archives? The answer to this question is both prosaic and dramatic. Yes, the original negatives were indeed destroyed. But this was not the result of a sinister conspiracy to cover up the truth. It happened in 1975 by official order. The initiator of this decision was Yevgeny Krinov, at that time chairman of the Meteorite Committee of the USSR Academy of Sciences and one of the most prominent researchers of the Tunguska problem. The reason was purely technical and related to fire safety. The fact is that all these negatives were shot on nitrocellulose film. In the early and mid-20th century, this was the standard material for photography and cinema. However, nitrocellulose film had one extremely dangerous property. It was highly flammable and, over time, had a tendency to spontaneously combust. As it aged, it decomposed, releasing flammable gases. Fires in film archives caused by the spontaneous combustion of old film were a real scourge of the time and destroyed many masterpieces of silent cinema. By the 1970s, strict instructions were in place in the Soviet Union, as in the rest of the world, requiring old and dilapidated nitro-based archives to be destroyed after being copied onto modern safe film where possible. The archives of the Meteorite Committee, where Kulik's negatives were stored, were no exception. By order of Krinov, the old, fire-hazardous negatives were burned. Today, many researchers consider this decision barbaric and short-sighted. Original negatives always contain more information than any copies. Perhaps it would have been possible to see details on them that are not visible on the prints. However, from the point of view of an archivist at that time, acting on instructions, it was a logical and justified step to ensure the safety of valuable collections. But the most important thing in this story is that the information was not lost completely. First, positive prints were made from the original negatives, while Kulik was still alive. These 2,500 photographs were preserved and transferred to Tomsk for storage, where researchers could work with them and continue to do so. It was from these prints that scientists spent decades studying the morphology of the fallout, refining the coordinates of the epicenter, and building their models. Secondly, some of the negatives survived, possibly having been transferred to other institutions or simply lost in the archives before the Great Purge. Thus, the story of the missing films is a classic example of how a real fact, the destruction of the original negatives, taken out of context, the reason for the destruction and the existence of copies, turns into a sinister mystery. There was no conspiracy. There was a bureaucratic fire safety instruction and, perhaps, a lack of understanding of the unique value of the originals. This story is not about hiding evidence, but about the tragic vulnerability of physical media and how easily myths arise when there is no complete and clear picture of what happened. the truth turned out to be less exciting than fiction, but no less instructive. But what about the version that formed the basis of our investigation? The story of Soviet geophysicists who filmed something sensational on film in Tunguska in the 1960s, after which both they and their materials disappeared without a trace. If the real geophysicists of that time were engaged in routine scientific measurements and the only film was photographs from 1938, where did this exciting legend come from? The exact source of this myth is almost impossible to determine today. It belongs to the category of modern folklore, or, as they say now, creepypasta, which is spread on the internet and in popular pseudoscientific literature. However, we can analyze what elements it is made up of and why it has proven so enduring. First, there is a grain of truth in it. As we have already mentioned, in the 1960s, there were indeed many expeditions working in Tunguska, including geophysicists. This was a period of peak scientific interest in the problem. The very fact that they were working in this region is true. The myth begins where their open scientific activity is replaced by a secret mission. Secondly, the 1960s were the height of the Cold War. The atmosphere of universal suspicion, the arms race, secret military programs, and spy mania created the perfect breeding ground for such stories. The idea that the Soviet authorities could have found something in Tunguska, such as the wreckage of an alien spacecraft or a source of unknown energy, and kept it secret, fit perfectly into the logic of the time. Secret geophysicists are characters straight out of a spy novel. Thirdly, pop culture also played a role. In the 1970s, the Strugatsky brothers' novel Roadside Picnic was published, followed by Andrei Tarkovsky's film Stalker. Although they are not set in Tunguska, they popularized the idea of the zone, a place visited by aliens, where anomalies and artifacts remain, and which is under strict control by the authorities. This image of the zone was easily projected onto the real, mysterious, and inaccessible Tunguska. Finally, the very idea of a lost film is a powerful cultural trope. A lost film is not just missing information, it is a promise of revelation. It is a hint that there is irrefutable proof of something incredible, but they are hiding it from us. This idea is at the heart of many conspiracy theories, from the Kennedy assassination to the moon landing. Thus, the legend of the missing films and geophysicists is not a reflection of real events, but a kind of collage assembled from fragments of facts, Cold War fears, images from science fiction, and classic conspiracy cliches. It is so appealing because it offers a simple and exciting solution to a complex and confusing mystery. Instead of a long and tedious scientific search, it gives us a spy drama with aliens and the all-powerful KGB. It's a great plot for a movie, but unfortunately, it has nothing to do with the real history of the Tunguska phenomenon. This story is not about what happened, but about what people would like to believe happened. The second part of the legend, the disappearance of the scientists themselves, is an even more classic and, at the same time, completely unsubstantiated element of conspiracy theory. If the lost film hints at the concealment of information, then the disappeared witness is the highest form of this concealment, a transition from passive concealment to active elimination of those who knew too much. This motif is an integral part of virtually every major conspiracy theory of the 20th and 21st centuries. Remember the mythology surrounding the Men in Black, who allegedly silence witnesses to UFO encounters in the United States, or the numerous stories about the strange deaths of scientists working on secret projects, or the rumors about witnesses to the Kennedy assassination who died under mysterious circumstances. The mechanism here is always the same. A real person who was involved in the event is taken, and their death, even if it occurred naturally many years later, is declared suspicious and violent. In the case of Tunguska, this motive did not even find specific names. Legend speaks of abstract Soviet geophysicists who disappeared 2 years later. Who were these people? What were their names? Where and when did they work? There is no information on this, and this is not because the KGB archives keep the secret safe. It is because these people most likely never existed in the form in which they are portrayed in the legend. The real scientists who worked in Tunguska in the 1960s did not disappear anywhere. Many of them, such as the aforementioned geologist Kirill Florensky and academician Nikolai Vasilyev, head of the comprehensive amateur expeditions, lived long lives, wrote dozens of scientific papers and books, and openly published the results of their research. They did not hide information. On the contrary, they devoted their lives to collecting and analyzing it. Their names are well known in the scientific world. The myth of the disappeared scientists feeds on the image of a totalitarian state where human life is worthless and the secret services are all-powerful. This image certainly had real foundations in certain periods of Soviet history, but to apply it indiscriminately to scientific activity in the 1960s is to oversimplify the picture. By that time, science, especially in fields such as geology and astronomy, was a relatively open sphere. Of course, there was censorship and ideological control, but the mass physical elimination of scientists engaged in fundamental science, rather than defense, was not the practice of the time. Thus, the story of the missing geophysicists should be viewed not as a historical fact, but as a wandering plot that has become attached to the Tunguska mystery to make it even more sinister and exciting. It appeals not to reason and facts, but to emotions, to fear of the unknown and distrust of authority. This is a powerful, dramatic device that works well in film and literature, but falls apart at the first attempt to find any documentary basis for it. The real drama of Tunguska lies not in fictional spies and murders, but in the fate of real people, such as Leonid Kulik, who sacrificed their lives in the name of science in an attempt to solve one of nature's greatest mysteries. When scientific explanations seem too boring or incomplete, the human imagination comes up with alternatives. The Tunguska mystery has become the perfect testing ground for the most daring and sometimes crazy hypotheses. And the most popular of these is undoubtedly linked to extraterrestrial intelligence. The idea that an alien spaceship exploded over Siberia, first voiced by science fiction writer Alexander Kazantsev in 1946, has proven incredibly resilient. Supporters of this theory point to the same oddities: the absence of a crater and meteorite debris. They claim that the ship, possibly powered by a nuclear engine, crashed while entering the atmosphere or attempting to maneuver. It exploded in the air, which explains all the peculiarities of the destruction. Some go further and suggest that it was not just an explosion, but a deliberate act. The aliens allegedly saw that their ship was falling on populated areas of Europe and, at the last moment, diverted it to the uninhabited taiga, sacrificing themselves to save humanity. It's a cool story, but there's no proof other than some coincidences. Lots of UFO enthusiasts have searched for shipwrecks or weird artifacts at the crash site, but they haven't found anything. Another popular theory links Tunguska to the activities of the brilliant inventor Nikola Tesla. In the early 20th century, Tesla was actively experimenting with wireless power transmission over long distances. His Wardenclyffe Tower on Long Island was intended to supply energy to the entire world. Supporters of this version claim that on June 30, 1908, Tesla conducted a powerful experiment and, intentionally or accidentally, directed a huge burst of energy to one of the most sparsely populated areas of the planet, Siberia. This theory also has no evidence to support it. Tesla's diaries and records of his laboratory work contain no mention of such an experiment. Moreover, physicists claim that it was simply impossible to transmit such an amount of energy over such a distance and focus it at a single point using the technology of that time. There are even more exotic hypotheses. For example, that the Earth collided with a microscopic black hole or a clump of antimatter. Such an object, passing through the planet, could have caused a powerful explosion in the atmosphere due to annihilation or gravitational effects, leaving no debris behind. These theories are interesting from the point of view of theoretical physics, but they are also pure speculation. Astronomers estimate the probability of such an event to be negligible. There was also a volcanic hypothesis, according to which the explosion was caused by a powerful release of about 10 million tons of methane from the Earth's interior, which then ignited. However, geologists have found no evidence of such a large-scale gas emission in the area. All these theories, from aliens to black holes, have one thing in common. They try to explain the mystery in one fell swoop by proposing some kind of extraordinary event. The scientific approach, on the contrary, attempts to explain it through known laws of nature. And to date, the theory of an air explosion caused by a comet or asteroid remains the only one that satisfactorily explains all the available facts without resorting to fantastic assumptions. But a mystery is a mystery, and it's there to stir the imagination. Until the last irrefutable piece of the cosmic visitor is found at the site of the Tunguska explosion, the flow of alternative versions will most likely not dry up. When reality leaves so many blank spots, culture steps in. The Tunguska catastrophe, with its mystery and scale, has become an inexhaustible source of inspiration for writers, filmmakers, musicians, and game developers. It has become a powerful cultural myth that lives a life of its own, often bearing little resemblance to actual scientific data. Perhaps the most significant work to emerge from the Tunguska mystery is the novel Roadside Picnic by the Strugatsky brothers, written in 1971. In it, the authors do not mention Tunguska directly, but create the concept of the zone, a place visited by aliens who left behind anomalies and artifacts. This image perfectly fits the idea of Tunguska as a place of contact with extraterrestrial intelligence. This concept gained even greater popularity with Andrei Tarkovsky's 1979 film Stalker, based on the novel. The film's gloomy, philosophical atmosphere and visual imagery forever linked the image of a mysterious, forbidden, and dangerous zone with the Tunguska event in the popular imagination. Tunguska also left its mark on Western culture. It became a popular element in science fiction series. For example, the cult series The X-Files features the Tunguska theme in several episodes. In the series, an alien spacecraft crashed there, bringing a black oil virus to Earth, and the Soviet authorities set up a gulag at the crash site, where they conducted cruel experiments on people in an attempt to create a hybrid of humans and aliens. This plot is, of course, pure fiction, but it has cemented the connection between Tunguska and aliens and sinister government conspiracies in the minds of millions of viewers around the world. Tunguska also appears in the world of video games. In the Resistance and Tomb Raider series, it also appears as a place associated with extraterrestrial artifacts or mutations. In the Assassin's Creed series, the Tunguska event is explained as the result of the activation of one of the artifacts of the ancient civilization of the Forerunners. Each such appearance in pop culture, whether in a book, film, or game, serves to reinforce the myth. It takes a real mystery and offers its own, usually fantastical and exciting version of the answer. Millions of people who have never read scientific articles about Tunguska learn about it from these works. And for them, the version about aliens or secret experiments becomes the main, if not the only, one. Culture does not seek the truth, it seeks a good story. And the story of the fall of an ordinary, albeit very large, piece of rock or ice loses out in drama to the story of a UFO crash or a conspiracy by the secret services. Thus, a vicious circle is created. A real mystery gives rise to a myth. The myth is replicated and embellished by culture, and culture shapes public opinion, which begins to demand confirmation of the myth from reality. And the Tunguska phenomenon is perhaps the most striking example of this process in the 20th century. While culture creates myths, science continues its painstaking work. In the 21st century, researchers of the Tunguska problem have access to tools that Leonid Kulik could not even dream of. First and foremost, these are powerful computers capable of performing complex hydrodynamic modeling. Scientists from leading global laboratories, such as Sandia National Laboratories in the US, are creating three-dimensional models of a space object entering the atmosphere. They can vary its size, composition, density, speed, and angle of entry, observing which scenario most accurately reproduces the picture of destruction recorded by Kulik and subsequent expeditions. These simulations showed that a body with a diameter of 60 to 100 meters, consisting of rock but with low strength, entering the atmosphere at a shallow angle, should indeed have exploded at an altitude of about 8 to 10 kilometers, with the release of 15 to 20 megatons of energy. The results of the modeling coincide strikingly with the actual picture of the forest fall, including the butterfly shape and the presence of telegraph trees. This became a powerful argument in favor of the main asteroid hypothesis. Another important area of modern research is the analysis of lake sediments. Lake Checo, located 8 kilometers from the epicenter, has long been considered a candidate for an impact crater. In the 2000s, a group of Italian scientists drilled into the bottom of the lake. They found that its cone shape and the structure of the bottom sediments were very different from other lakes in the region. They suggested that the lake was formed at the site of the fall of a large fragment of the Tunguska body. However, other researchers, drilling even deeper into the bottom, found that the age of the lowest layers of silt was not 100 years, but several hundred or even thousands of years. This means that the lake existed long before the disaster. The debate surrounding Lake Checo continues, but most scientists are inclined to believe that it is not a crater after all. The third line of research is the search for microscopic material from the body itself. The idea is that after an air explosion, tiny particles of a meteorite or comet must have settled on the ground and been preserved in the peat layers dating back to 1988. Russian and foreign expeditions continue to take samples of peat and resin from old trees that witnessed the event, trying to find isotopic anomalies or microscopic particles with extraterrestrial composition. From time to time, there are reports of finds of minerals such as Lonsdaleite or troilite, which could indicate a meteorite origin. However, these finds are still isolated and do not allow us to draw any definitive conclusions about the exact composition of the Tunguska body. Thus, modern science, using the power of computers and sophisticated analytical methods, is getting closer to solving the mystery. The picture is becoming increasingly detailed. We already have a fairly good understanding of the mechanics of the explosion. But the main question, what exactly it was, a comet or an asteroid, remains open. For a definitive answer, the most important thing is missing, an irrefutable fragment of that very heavenly visitor that paid a visit to the Siberian taiga more than a century ago. The search continues. More than a century has passed since the day the sky split over the Siberian taiga. Dozens of expeditions, thousands of scientific articles, endless debates. And what do we have in the end? On the one hand, we have a coherent, logical, and well-founded scientific theory. It states that it was an air explosion of a cosmic body. most likely a stony asteroid, but possibly a comet. This theory explains almost all the facts: the monstrous power, the absence of a crater, and the strange shape of the forest fallout. On the other hand, we still do not have the main thing: material evidence. Not a single gram of material that could be said with 100% certainty. This is a fragment of the Tunguska meteorite. And it is precisely this gap between a convincing theory and the lack of definitive evidence that is the fertile ground on which all myths, legends, and conspiracy theories grow. The Tunguska mystery turned out to be a perfect storm. First, the event itself was incredibly grand and spectacular. Second, it happened in the most remote and uninhabited place possible, ensuring the absence of reliable evidence and allowing nature to hide its traces. Third, the historical context, wars, revolutions, the Cold War, left its mark, creating an atmosphere of mystery and mistrust. The story of the missing films and disappeared geophysicists with which we began our investigation is the quintessence of this myth-making. It takes real facts, Kulik's aerial photographs, their subsequent destruction for technical reasons, the work of scientists in the 1960s, and, taking them out of context, weaves them into a thrilling but completely fictional story. Why do we so easily believe such stories? Perhaps because they give us a sense of involvement in something grand and mysterious. They flatter our intellect, suggesting that we, unlike official science, know the truth. Or maybe it's just because a story about a Secret Service conspiracy and a UFO crash is always more interesting than a boring analysis of peat deposits. Tunguska teaches us an important lesson: how to distinguish fact from fiction, how to be critical of information, and how easily the human mind creates legends where it lacks knowledge. This is a monument not only to the colossal power of nature, but also to the boundless power of the human imagination. And until the last fragment of the Tunguska visitor is found, this mystery will remain suspended between heaven and earth, in that very space where science meets myth.